Hey everyone, today we're going to talk about a very important concept in AP statistics, scatterplots and correlation. If you've ever looked at a graph full of dots and wondered what exactly am I supposed to say about this, don't worry. By the end of this video, you will know exactly how to describe it in AP level language. So, what is a scatterplot? Let's start with the basics. What is a scatterplot? A scatterplot is a graph of an explanatory variable versus a response variable, and each individual is represented by one point. Both axes are quantitative variables. In simple terms, it's basically a scatterplot shows the relationship between two numerical variables. So it may still seems abstract, and don't worry, we'll step into a variable to talk about this. So let's look at this example involving Florida boat registrations and the number of mentees killed by the boats. And you can see that the x-axis is the explanatory variable, which label it right here. The table gives us like basically two columns of data, and those are the data we're going to focus on in this video to analyze deeper. And the y-axis, which also calls response variables, is the number of mentees killed. And the explanatory variable is also an independent variable, and the response variable is also called the dependent variable. Maybe the term that sounds familiar right now. So this is basically a bivariable data, which means two variables. And that's basically the same thing like what we are going to do next to create a scatter plot. So let's take a look at how are we going to do it. So this is the scatter plots and linear regression, and the scatter plots and correlation first. So scatterplot, you can see, is the graph of explanatory US response variables. Each subject is a dot. You can see it. I copy and paste a screenshot of my calculator, the data that basically they follow the same trend. And there's two quantitative axes, which we label it right here. So the x-axis, just as we said in here, is the explanatory variable, which is the number of boats registered. And the y-axis is the number of mentees killed, the response variable. So whenever you construct a scatter plot, make sure you label both the x-axis and the y-axis. This is pretty important. And just as said right here, this is a bivariate data, and which means that there are two variables, and each here gives us one pair of values. When AP asks you to describe a scatter plot, you should always talk about four things: strength, direction, form, and outliers. So strength describes how closely the points follow a pattern, usually a line. Common words you can see or you can use is strong, moderate, or weak. If the points are tightly clustered around a line, that means it's strong. If they're more spread out, it's moderate or weak, most of the cases. And the direction tells us which way the trend goes. If it's a positive association, which means as x increases, y increases. If it's a negative association, is as x increases, y decreases. And in this example, as the number of boats increases, the number of mentee deaths increases. So the association is positive. And then the form. The form is describing the shape of the relationship. The most common forms are linear and nonlinear. Here the pattern looks roughly like a straight line, so we say the relationship appears to be linear. Last but not least is the outliers. The outliers are points that fall far away from the overall pattern. Always check, are there any unusual points, or do they affect the trend? I mean, like, both of the questions you will want to ask yourself before you start to write the conclusion. So putting it all together, a strong AP-style response would sound like this. There is a moderate, positive, linear relationship between the number of boats registered and the number of mentees killed by boats. there do not appear to be any strong outliers. So basically what I wrote right here. And right now, and here I kind of like drew some different scenarios for the 4 components we just talked. So talking about the strength again, if it's a strong relationship, then you can see most of the dots are like lined in one straight line. If it's a moderate, then it's kind of a little bit away from the line, but you still can see a clear pattern. If it's weak, then you really cannot see any pattern. I mean, like, you can see that a little bit of the pattern, but it's already start to feel blurry. If it's no pattern, then basically it just clustered of nothing. So a little tip that I use to help me identify if the relationship is strong or not is pretend you're using a highlighter and imagine how thick the stroke is. If this stroke is pretty thick for you to shade all of the dots, then probably it's a weak or moderate relationship. If it's pretty thin or pretty easy for you to draw a straight line, covers all of the dots, then we have clear evidence to say it is a strong relationship. And think about the direction. The positive will be pointing this way and negative will be pointing this way. And the outliers will be like, basically this will be considered as an outlier. And in here, this is also a kind of outlier, but it does not shape the slope very much, because you can see that even though it's outside of the normal like X ranges of the data, it still follows a same pattern. Not as this one. This is kind of out of the bounds. And linear versus non-linear. A linear is basically the data you cannot see any pattern. If it's a non-linear, then you can see some weird shape. For example, this will be like a weird shape we consider as. So comment on the relationship you see in the scatter plot at the top of the page. We already did right here. Okay. So linear relationships are common, and it is difficult to judge the strength of the association between the explanatory and response variables by eye. We use a numerical measure of association to help us. It has a fancy name, and its computation is anything but simple. But we'll refer to it simply as correlation, or even more simply, R. AP will also sometimes refer to this number as the correlation coefficient. This is the formula for R. And it seems scary at the beginning, but don't worry, we won't ask you to compute it in your exam. You won't do it by your hand because we have calculator, we have TI-84 to help us. So R is between -1 and 1. This is always true. Like, this is the range of R. R cannot exceed those two bounds. And R is basically the measure of how linear data are. And it seems like it also gives us scenario Texas instruments to this rescue. Our calculator will handle the calculation, yes. But there are a number of facts about R that we must know. So yeah, so in here we're going to talk about R a little bit. So after just reading all of those paragraphs, it seems still pretty ambiguous. I know, I get it. So we're going to talk about correlation, also called R, more in depth or in a more easier way for you to understand. So the correlation measures how strong and how linear a relationship is always between -1 and +1. And the key ideas is R is positive, like R is greater than 0, then there's a positive association. The data will be right here, like this. If R is less than 0, then there's a negative association, like this. If R is equal to 0, then no linear relationship. And important note is R equal to 0 does not mean no relationship at all. It means no linear relationship. This is a pretty easy to confused. So like be sure you do not fall in that trap. And important properties of correlation, here are facts you must know. So both variables must be quantitative. Switching x and y does not change r. Correlation has no units. Correlation measures linear relationships only. And correlation is not resistant to outliers. So what does resistant means? Resistant is like, for example, if you have an outlier can change the whole pattern or whole overall trend of the data in your scatter plot, which can change R. Remember, R is only for linear data. So using your TI-84 to find R when your data is in L1 explanatory and L2 response, we'll do this later in the videos. But just know that when you're putting your data into your calculator, L1 is always with X values, L2 is always with Y values. You must select diagnostic on in your TI catalog for R to be displayed. So be sure to check that before you actually enter data into a calculator. Then follow the key sequence. Stat, calc, 8, select linear regression, A plus BX. Then go into X list, L1, Y list, L2, store regression equation, variables, Y variables, 1, function, and then Y sub 1. So all of those steps I will like walk with you later in the videos, but as it for today is only a introduction, like an overall summary for what we're gonna be focused on in Unit 2. So just have a big picture in your mind is it's enough. So final reminder is scatter plots help us to see relationships, and correlation helps us measure how linear they are. Always describe strength, direction, form, and outliers in that order. And if this video helped you understand scatter plots and correlation, feel free to check out my other AP Stats videos. Thank you so much for watching, and I'll see you next time.